second equation. Now if I substitute this here in the first part, this value which I have done here, if I substitute this here, these two will be cancelled. Only answer is okay. Therefore, let me substituting this value in first, from first and second, from first and second, putting value of son of integration dx x cos x dx in first from second, in first from second. From second, what do we get? This is the value of dx x cos x. So if I substitute this here, what do we get finally? Finally we obtain, let me write here, finally we obtain sin of integration dx in bracket x cos x plus sin x into dx is equal to this value, which is 1.2 x cos x e over x minus 1.2 cos x dx. This is minus sin x, sorry. This is sin x e over x into dx plus 1.2x plus 1.2, sorry, this one 1.2 x sin x into e raised over x, okay, e raised over x. This one 1.2 sin x e raised over x. Now this value is plus this last part of this from first equation, the sin of integration sin x into dx into dx, which is plus sign. This plus sign is minus sign cancelled out. Finally, these three steps are done. First, second, and third. These are the three answers. Let me take common. 1.2 dx if I take common. 1.2, 1.2, 1.2 dx common. First will be x cos x minus sin x. This is cos x only. Cos x here plus x sin x. X sin x here plus constant of integration. This is the answer of the question. Question number 11th we are done. Question 11th is finally solved. Okay, so let me take the next question. 12th. Now question number 12th, what did it say? Let me check it. Question number 12th. Let us discuss about 12th is here. Sin of integration, this is 12th. Sin of integration, which is x cube dx into sin x. Okay, dx into sin x. dx into sin x into dx. This is the value of question number 12. This is dx into sin x into dx. dx into sin x. dx sin x into dx. This is question number 12, which we have done by our own way. If I integrate dx sin x by product by parts method separately, then multiply by x cube. When x cube will be there, let me integrate first dx sin x, integrating. Now integration of dx sin x dx by using by parts method, using BP method or by parts method, we get now dx for integration second function, this is first function, first function, second function. This we always complete by Eilert method. Okay, by Eilert formula, I means inverse function, E finally exponential function, second function. Integrating this is sin x as it is. Integration of Px is dx minus sin, differentiation of sin x. Px integration of dx. This is the value. Now further integrating it by cos. Integrating it again by cos. Integrating it again by cos. We get sin x dx as it is minus sin. First function, second function. Cos x as it is. Let me do it in bracket. Ex integration is dx minus sin. This will be plus sin. Why? Cos x difference is minus sin x. It is plus sin x now. Well, this minus sign was already there, in between we keep, and minus sign will come from inside because differentiation of cos x into minus sin x. Integration of dx is dx into dx. Okay, now let me separate it, open it by minus sign. Here it will be sin x dx minus sin cos x dx minus sin of integration. This is sin x into dx into dx. What do we see? This is the same value which we integrated. Dx sin x. Dx sin x. This is sin of integration dx sin x into dx. This is the value. Same value we have obtained here. Transferring this to the left hand side. This implies that 2 times sin of integration dx into sin x into dx. Because taking this to the side, one time, then we added up twice there, is equal to this value, which is dx in the bracket of sin x minus cos x. These two steps are there. Therefore, integration of this. Yes, therefore integration of dx sin x dx into 1 from 2 dx, and in bracket it is sin x minus cos. Now if I keep this, or let me put sin x cos x, if I multiply this by 1 upon root 2, no problem, and multiplying this by 1 upon root 2 and 1 upon root 2. Will be sin 45, cos 45 degree, sin 45 degree can be written down there. Okay, so it can be multiplied by, let me take this is root 2 upon 2 dx, so multiply this by 1 upon 2, the root 2 and divide by root 2, no change, it is sin x minus 1 upon root 2 into cos x. It can be written as root 2, that is 1 upon root 2. So if I multiply numerator and denominator by root, rationalizing this, it will be 1 upon root 2 only. Yes. Now 1 upon root 2 can be written as cos 45 degree, sin 45 degree. It can be written as sin x into cos pi by 4 minus sin. It is cos x into sin pi by 4. What it will be? It will be equal to 1 upon root 2 px over x. In the bracket is sin a cos p minus cos a sin. It is nothing but sin x minus pi by 4. This is the final integration of this. Integration of this is this. Let me keep it for there. Therefore, integrating it by parts. First one, integration of this, we will take this as the second function. For integrating this is the first function. Now integrating. Okay, now so integration of dx sin x dx is this. This will be used in the second equation. The first one is this. to substitute the value of this integration. The first one, when we integrate this, what is the formula for this integration? Now integrating first equation by parts. Now integrating first by parts. By parts we get considering ex sin x as the second function. Second function. Okay. Now what do we get? We get here, therefore integration of this will be x3 as it is. Integration of ex into sin x into dx minus sin differentiation of this x, which will be 3 into x square into integration of dx into sin x into dx, this whole dx. Now substituting this value, because integration of this dx sin x, dx sin x, dx sin x in this. But substitute this value there, what will be? Finally we get x here, sin of integration is 1.2 into dx sin of x minus 5 into divided by okay, minus sin this is 3 x square into integration of this is the same value, which is upon root 2 dx into the whole value dx into sin of x minus 5 by 4 okay into dx. Now it can be further integrated this dx sin x as we integrated. What it will be? Next integration will be twice of this, because as I discussed yesterday, in the previous question, maybe the previous one of the questions, there it was alpha, x minus alpha, then it was x minus twice alpha. I integrated it again. Integrating this okay, by parts again, you get ex sin x minus twice into alpha. Alpha is here 5 by 4. Twice of that will be. Further integration will be, let me integrate this further. Similarly, now integration of dx sin x minus 5 by 4 into dx will be equal to, again 1 for root 2 will come out, because 1 for root 2 will again come out into dx into it will be sin x minus 2 pi by 4, twice of this. So this is the integration. We can do simply as we did yesterday, but in that denominator we get, because coefficient of x is 1. Coefficient of x is 1. 1 square is under root a square plus b square as we did. Because 1 under a square plus b square is being multiplied. This value is just twice of this value. This integration, therefore, this value, if I substitute there, therefore x square into ex sin of x minus 5 by 4 will be integrated as x square as it is. Integration of this is 1 from dx into sin x minus 5 by 2. Now this is 5 by 2. This is the integration. First function as it is, this is x square. X square as it is, this is first function. And these two are second function. Integrating this, we are integrating this value. We will substitute this in this equation. This let me take second equation. Because in second this equation, I substitute in place of x square ex sin x minus 5 by 4 which we are calculating, which is this one. X square into integration minus sin. Okay, now this is twice from 2 twice x with x again, dx into sin of x minus pi by 2 into dx integration. Further it will be integrated again 1 point 2. Further x integration of x e to x sin x into x minus pi by 2 into dx equal to x, as it is integration of this whole will be again 1 point 2 into dx into sin of x minus pi. And again we have to multiply this by 2, it will be minus 2 pi upon 2, that will cancel out, integration hence minus sign in between. It is now 1 only this dx into sin x minus 1.2 3 x minus pi will come here into dx. One time more this is to be integrated, dx into sin this will be only 2 pi 1.2. This is further integrated, let me write it as x into dx sin x minus pi divided by 2 minus sin. This is further integrated, it will be 1.2, that means 1.2 only into dx sin x minus, now it will be 2 pi because twice multiplied 2 pi, it will be 2 pi only. This is third equation. Now let me put this value of this x minus, first of all this is fourth equation, let me take the fourth equation, this is the third equation here. First we have to substitute the value in the third equation, so let me take it in this equation only. Then in between we will substitute these values from 1 by 1. First I have to substitute the value of this, which is this much 2 upon root 2. Okay, here it is. Then x ex sin pi by 2, x minus pi by 2 will be this value. This are let me write these step by step here in this equation. So what we will get finally 1.2, it is coming out, x cube dx into sin x minus pi by 4 upon first step minus sign. Now this is, let me take 3 upon 2. Now x square ex sin x minus pi by 4, this value is this. First is x square upon root 2 dx into sin x minus pi by 2. It is pi by 4, it is now pi by 2 minus 2 upon root 2 curly brackets. Now value of this x ex sin x minus pi by 2 is equal to this. This we have to substitute, it is x sin x minus pi upon root 2 with minus sign 1.2 dx sin x minus 2 pi. Okay, now this is complete because from third one 2 upon root 2, this 2 upon root 2, then this value is from fourth equation. I have substituted here from equation second, third and fourth. This is from second, third and fourth we have got. We have obtained this equation. Now finally let me multiply this and separate each term. So what do we get? The final answer will be there. Okay, so what the final answer? Final solution of this question is that we solve it now. So this is x cube. If I take dx common throughout, can be taken. Okay, so if I take dx common, it will be dx common are taken out, we x cube into sin x minus pi upon 4 upon root 2, the first value, minus this is 3 upon 2. Okay, it will be 3 upon 2 x square into sin x minus pi by 2, the system. 3 upon 2, this is 3 root 2 upon 2. You can it out, it will be only 3 minus plus 3. It is plus 1 because root 2 will be 2 and you cancel out 3 upon 2 for 3 upon root 2 this value. It is x into sin x minus pi. The first value we have taken. Again, this 2 to cancel out, only 3 was coming. So this is 3 upon 2, second is. This time will be 3 upon 2 only. Why? Because the root 2 cancel out, only 3 was coming. Multiplication of this whole will be minus 3 upon 2. Well, sin x minus 2 pi. Dx we have taken out. This is whole value plus a constant of integration. Okay. So first x minus pi by 4, x minus pi by 2, angle x minus pi and x minus 2 pi. This is angle. And the value is minus 3 by 2, minus 3 by 2, 3 upon root 2 is the answer to plus 2. Finally, this is answer. Question number 12, we have done. Now let me take 13th question. What is question number 13 say? Now question number 13th. Let me check it. What is this? Question number 13th. This is sine of integration 0 infinity. Limits are 0 infinity. Okay. This is x is equal for minus 2x. Cos x into dx. Okay. Again, e raised power minus 2x into cos x. That I will separately integrate. So integration of, then I'll integrate with this x into this whole. Integration of e raised power minus 2x into cos x dx. Integrating this as first function, second function. Sorry, this first function cos x is first function, this is second function. Integrating it, integration of this by parts will be, what will be integration of this? It is nothing. So there is nothing is required. Only we have to solve it. So 17 questions are there. Open the process 13th. Now by parts, if I solve it, it will be cos x as it is. Integration of e for minus 2x, integral for minus 2x upon minus 2 plus sin cos x. Differentiation of cos x is minus sin x, that is plus sin x. But integration of e minus 2x, so e minus 2x upon minus 2 into dx. Again, it is to be integrated. It is nothing but minus 1.2 cos x is for minus 2x minus sin 1.2. Sin of integration, this is sin x. So it will be for minus 2x dx. Let me integrate it again by parts. What do we get? The minus 1.2 cos x e raised to power minus 2x minus sin. So if I take 1.2 common, then consider it as the first function, second function again by parts. Again integrating it by parts. Again integrating it by parts. We get now sin x as it is. Integration of e minus 2x upon minus sin. Now again we minus sin over this minus 2. If I take one from out, sin x differentiation is cos x positive. Therefore minus 2x upon minus 2 which I have taken already out. This is the same function which we were integrating. But let me take this function here. Let me separate each term. It is minus 1.2 cos x e power minus 2x. Minus this is plus 1.4 sin x e power minus 2x. This one minus plus. Sorry, this minus sign and this is minus sign. It is plus sign here. Now we are integrating the sin x cos x. It is with negative sign. It is with minus sign, minus plus sign. They will triple negative. Okay, I'm sorry. Now this is plus sign here, reason. Because in between we do negative sign. But because of this minus 2, it has become positive. Why? Sin x as it is integration of e raised to minus 2 x e raised to minus 2 upon minus 2 plus difference of sin x cos is positive. But we keep minus sign in between, then it will be e raised to minus 2 x upon minus 2 plus. It is now minus sin 1.4. Sign of integration is cos x e raised to minus 2 x into dx. Alright, this can be taken to the left hand side with this, where we are integrating this function. Sign of integration e raised to minus 2x and cos x into dx we are integrating. If I take this 1.4 this side, it will be 1.4 plus 1 will be 5.4. So 5.4 sign of integration, this is e raised to minus 2x and cos x into dx is equal to this value of this. These two are there. It will be minus 1.2 cos x e raised to minus 2x plus sin 1.4 sin x e raised to minus 2x. These two steps are there. We take e minus 2x common and also okay 1.4 common, effective 1.4 common, minus 1.4 common, and e minus 2x also common. What it will be? It will come out as cos x. Why is cos x? Because 2 times cos x. 2 times cos x minus sin, well minus sin of common. It will be sin x only. Again, if I take 2 as r sin theta, or sorry, r cos alpha, this is r sin alpha, here alpha is taken. It's taking this in 1, okay, so then it will be integrated. First let me find out this value. This is e raised to minus twice x into cos x into dx. Integration is minus 1.5 e raised to minus 2x only. The 4 to cancel out. Within bracket it is 2 into 4 x minus sin, it is sin x. If 2 equal to r cos alpha and 1 equal to 1, we take if 2 equal to r cos alpha and 1 equal to r sin alpha, then therefore r is equal to under 1 is equal to 2 is equal to 5 into 5, r is equal to, and alpha is equal to tan inverse We tan inverse 1 upon alpha is this. It is what? If I write 1 upon, it will be cos alpha. R will take common. It will be under root 5 because R upon this is R square. 1 upon root 5 will be there in the derivative. What do we get here? Now let me calculate this value. So we are solving these two functions from the beginning. This has come out to be here. Let me write this one here. So what is this value? It will be R effective common. It will be cos A cos B minus sin A sin. It will be cos A plus B. That means cos x plus that value. It will be cos x plus cos in here. It will be cos x plus something. It will be right. It will be minus 1.5. That means 5. Why? Because R I will take common out of this, these two. R is 1 point root 5 only. Root 5 on 5. It will be 1 point root 5. And P is or minus 2. In bracket it will be cos of x plus 5 by 4. No, I'm sorry. It is alpha only. It is alpha. X plus cos x plus alpha. Cos x plus alpha. This value will be. Why? So it will be 2 is R cos alpha. 1 is R sin alpha. So cos R are taken common. It will be cos A cos alpha, cos x cos alpha minus sin x sin alpha. It means cos A plus B x plus alpha. Where alpha is, let me write here. Where alpha is going to tan inverse 1.2. See 1.2. I'm sorry. And R is going to be 5. And R is, let me write B equal to R cos alpha. 1 is equal to R sin alpha. Therefore, R is equal to 5. B square plus 1 square is equal to R square equal to this square. That means R square equal to 5 or R equal to 5. Okay, so now if I integrate it again, what is the first function? Therefore, now I'm not applying the limits. Still, I'm not applying the limits. Only I will apply the limits. Therefore, integration of x_n. First I'm writing the integration. x_n e raised to power minus twice x into cos of x into ds will be equal to first function x as it is. These two are second function. Integrating it by parts.